Hi, this is Craig Stocks here for Utah Desert Remote Observatories. You can find us online at utahdesertremote.com, and we'd love to talk to you about hosting your telescope under our dark skies. And I also want to remind you that we do have a masterclass coming up September 10th through the 15th of 2023 here in St. George, Utah. And it'll be myself and Dr. Christian Sase, who is the principal astronomer for itelescope.net. And we're going to be covering a combination of both Milky Way night sky photography and deep sky astrophotography, so a little bit different. If you're interested in that, be sure to check out the website. Again, that's utahdesertremote.com. What I really want to talk about today is how to turn this image into this image, and it'll be a combination of Pixinsight and Photoshop. So I don't think I've really done much with one-shot color, which this is a very simple one-shot color image. It's about 50 frames at 5 minutes each, around 4 hours of data. No dual narrowband or any other complicating factors, just simple one-shot color. It is through just a plain glass filter that I use as my luminance filter. The reason I do that is because I have a dual narrowband filter and some other filters in a filter wheel. And if I don't have some sort of a filter, then the focus distance is too much different between a filter and just no filter. So I have to have a plain glass filter in there just to keep the telescope and camera somewhat parfocal, so the autofocus has a fighting chance of getting in focus. So with that, let's jump over into Pixinsight, and I think I'm going to do this as two videos. So the first one will be focused on the Pixinsight process, and we'll go a little bit deeper into the fundamentals of processing a one-shot color image in Pixinsight. And then the second video will go into Photoshop and look at the kind of the final steps of putting it together in Photoshop. And I do want to mention that the videos I do on YouTube, I think you could consider more of a demonstration than a true class. It's not interactive. It's designed to demonstrate how to do things in a way that hopefully you can follow along. But it's not the same as actually being in a classroom where I'm more focused on teaching fundamentals. So with that, let's jump in. As I mentioned, this was captured last night. It's about 50 frames with a one-shot color camera. And the first thing I always do in Pixinsight is go to the blink tool to make sure all the frames are usable. And to do that, from the top menu bar, you would go to Process, Image Inspection, and Blink. And then once there, you have a set of icons at the bottom that you can work from. If you use the first one, which is the Open or Add Image Files, you simply navigate to the folder where you have those files captured, and this is it right here. You'll notice I have it labeled as the Dark Shark, and it's actually the Angelfish Dark Nebula. The reason is when I first set out to image the dark shark, apparently I accidentally grabbed the wrong catalog number to plug into my software to aim the telescope. It was busy over the weekend, and I didn't really have time to look it over and make sure I had everything lined up correctly. I just kind of plugged it in and turned it loose. Well, it turned out I was imaging the Angelfish Nebula rather than the Dark Shark Nebula. So the title of the data is incorrect. This is the Angelfish Dark Nebula. So click on the first image, and then you can use keyboard Control A to select all of the images, or you can click on one, shift click on the other end, all the various ways that you would open files. Click Open, and this will open those 50 files to quickly blink through and look at them. If you have a mixture of different filters, You may need to tweak the auto stretch. In this case, I'm really just looking at stars, and are the stars round? And to do that, we don't need a very precise screen stretch. Pixinsight does automatically apply a screen stretch, and we can zoom in a little bit so we can see the stars. And what I usually do is click on the first image, and you need to do that in order to get the focus on this image. And then you can use the cursor keys to step through and just look for any images that are a little bit of an outlier. If I find one that looks like it's not usable, and remember, bad data doesn't make up for insufficient data. You're much better off to use fewer good frames than to include bad frames. If I find one I don't want to include, and let's say I don't want to include this one, Pixinsight doesn't really have a good way to take it out of the list. So what I do is move it to a rejects folder. And to do that, if you look at the icons that are now lit up across the bottom, the one we want is the fourth one from the left, and this is move selected file to a new location. So I just click on that, and then I will navigate to my folder that I have labeled as rejects. Select that, and I'm going to even move this up so that my select folder button is going to be close to the move file icon. Click on select folder, and it moves that file out of the main folder and into the rejects folder. Then I can click back on the image where I left off and continue stepping through. If I find any others I want to take out, again, I just click on the move selected files, select folder, and off it goes. Once I've gone through, and once you do that, you do have to click back into the list in order to reestablish focus, in order to use the keyboard shortcut. Once I've done that, then I can close the blank tool, and now we're ready to actually integrate the data. And of course, WBPP, the weighted batch preprocessor, is the tool of choice for this. And to get to that, you would go to Script, Batch Processing, Weighted Batch Preprocessing, and that will, it seems to do a little housekeeping before it actually opens the dialog, but it will bring up the screen that we can set everything up. I'm going to show you how I do it. For me, it saves time. First thing I do is load the light frames. And you see there's a set of tabs across the top, and these are the tabs where the different data groups will be stored or shown. The tabs on the bottom, or the buttons along the bottom with the plus signs, are where you actually load those. So to load lights, I would click on the plus lights, and by default it's still at the last folder that we looked at. So again, I can just click on the first one, use Control A or scroll to the bottom and Shift click on the second one, click on Open, and there's all my light frames, and there are 48 frames at 5 minutes each. To load all the rest of the files, what I've done is take the calibration files that I normally use and just chunk those all into a directory. And Pixinsight has an option to load a directory. So I'll click on plus directory, and I'll navigate to my calibration folder, and I have this color combined. So this is the color camera and the combined calibration set. Select folder, and that's going to load the darks and flats and bias frames. And generally I don't use them all. Sometimes I'll go through and take out the ones I'm not using. Most of the time I just let them go along for the ride, because Pixinsight caches the file, so it doesn't really take much time. But there are my flats, there are my darks, and there are the bias frames if they're needed. I have 10-minute, 5-minute, and 2-minute darks, and then flats for both the L-enhance filter and the luminosity. Those are the combinations I use the most with the color camera. If I wanted to clean things up, I could, for instance, click on this enhance group and just remove selected. And that way I don't have any extra calibration frames. but it doesn't really take much extra time to just leave everything in and not worry about it. And Pixinsight will sort out what it needs and what it doesn't. So if we go to the Calibration tab, and we have to do a few things to configure this, I have to first of all tell it that these flat frames are color filter array images. And so I click on the flat group, and then over in the settings, and these settings will change depending on what you've clicked on. Under CFA, that stands for color filter array, and that is characteristic of a color camera. So I would click on CFA, and you can see that this little icon in the list changed from no to yes, that these are CFA images. I need to do the same thing with my lights. Right here are the CFA settings. Again, I have to click on CFA, and then it's not able to pick out the Bayer pattern automatically, so I have to click on this auto and tell it that my camera is an RGB sequence. Now if I had multiple filters like luminosity and L-enhance and so forth, then I could just click on this apply to all light frames, and it would apply this setting across the board. I usually also set a pedestal value of something like 300, and again I can apply that to all light frames if I had more than one group, but it's applying it a group at a time. Last thing we need to do is come over here to the registration and reference image, and typically the first time through you would pick auto. If I run the same data again, like tomorrow night, if I added some data, then I would choose manual, and I would look in the log file to find out what reference image was used the last time. To do that, for instance, I would just go to my Internet Explorer or my File Explorer. Here's the Angelfish Nebula in the swap files. I did name it correctly. And you can see there's a set of folders for calibrated, debayered, logs, master, and registered. If I open logs, this is the log file from when it ran this data. If I open that, it will open it in Notepad. I can just do a quick Control F to find, search for a reference, press enter, and that jumps right down to where it selected the reference frame. And then I can scroll down just below that and see that the reference frame it chose was right here, number 383. So if I wanted to match this, this was in the debayered folder and number 383 in the luminosity. So I would I would set this to manual, open the folder to go specify the reference frame, go to the, where's it at? Must be under Dark Shark Centered. Oh, we need to go to our swap files. There we go. Angelfish Nebula. It's under debayered in the luminosity, which this is the luminosity. And the number we were looking for, you probably remember even though I don't. Let's see. 383. So I would just scan down the list of files looking for file number 383, and there it is. Click open. So now we're using the same reference frame that we used the last time. So if you're adding more data from a second night or a third night, you can use the same reference stars or the same reference frame, and that lets you kind of mix and match. If you had some data that was good from the first night, for instance with narrowband, I may shoot red, green, and blue plus the narrowband the first night, and if I have enough of red, green, and blue for the stars, I'll take those out of the sequence and just shoot narrowband the second night. By using this technique, I can still use those stars because everything is still aligned. So at this point, you would click Run, and it does a quick diagnostics, tells me that everything is okay. I've actually already run this data, so I'm not going to run it now, but you would just click on Continue, and Pixinsight would go off run through the process and give you the finished results. So let's jump ahead now, since I've actually already run this. When it's done, you can exit. Now, to open the file that we want to look at, and this is kind of the fun part, I usually just double click here on the background and the open dialog comes up. We just navigate to the folder that we used for our swap files and to the folder named master, and this has master lights and master flats, and it's the master light that I want. Click open, and since this is linear data, it's going to look very dark like this does. We can put a screen stretch on it by using this set of controls up here. This one is the STF auto stretch, or screen transfer function is what STF stands for. If I click on that, that'll just do a quick for reference only stretch. Usually it comes out with a strong color cast of some sort, which in this case it's pretty orange. And we can also see that there's a gradient going from left to right. So the first thing I do is use a dynamic background extraction that will remove the gradient and also more or less neutralize the image. And I have all of my process icons that I use most frequently saved over here on the right. And the first one that we're going to use is the DBE subtract. And this is already saved with the settings that I want to use for model parameters. We've got the tolerance of 2, shadows relaxation of 6, and smoothing factor of 0.25. And for image correction, it has subtraction selected. And it's hard to see, but I have a set of fairly large sample points arrayed around the perimeter. And I just generally just use those as they are. Click the check mark to process this, and this will give us a more or less neutralized image. And I can close this now. And for the most part, anytime you run a process, you need to refresh that screen transfer function with the icon at the top. Now we can see a little bit more of what we've got. You can start to see the Angelfish Dark Nebula here in the cloud of dust. A lot of stars that are really in the way. The next thing I want to do is spectrophotometric color calibration. Again, I have a saved icon over here, one for the one-shot color camera and one for when I'm using red, green, and blue filters with a mono camera. So double click on spectrophotometric color calibration. Again, this is already configured. I have the Sony color sensor for red, green, and blue. I've already loaded the Gaia reference data that you need to load before you can use this. And so typically what I do is just grab the process icon, drag it onto the image, and we're off and running. And this takes about 30 seconds to run. The tools all come as part of Pixinsight, but you do need to download the Gaia dataset. It's free, but there's a bit of a process to download it and then install it into your Pixinsight, which is basically extracting the files and then telling Pixinsight where those reference files are located on your hard drive. Once you've done that, then it can use the spectrophotometric color calibration to look at the star colors and try to balance the star colors with the Gaia reference images so that you have good representative star colors. And then generally once you've done that, you don't want to monkey with the color. At this point, it's just finishing up the background neutralization. It gives you this graph that shows how it did matching the white balance. The closer the dots are to the straight line, the better it did. This is good enough. So I'll just close this, and again we need to revisit the screen transfer function. Now we have removed the gradient and we have balanced the white balance to the star colors. Now I want to work with the stars, and this is pretty much the before image that I showed before. Everything is kind of hidden behind this cloud of stars. So we want to neutralize or reduce the stars somehow, and then that'll let us bring out more of the nebula detail. And I do this in a two-step process. So the first thing I'm going to do is duplicate this image. So I'll just right-click and choose Duplicate. And now I'm going to run Star Exterminator, and you'll see I use the full suite of Russell Croman's AI tools: Blur Exterminator, Noise Exterminator, and Star Exterminator. I highly recommend those. They're not very expensive, and they are like magic. They just do a great job. So the first thing I want to do is really knock these stars down, and to do that I'm going to use the Blur Exterminator with a fairly aggressive setting. I have the sharpen stars turned up to 0.32, where I think by default it's around 0.2 or 0.25. But again, since I have process icons saved with those settings, I just drag the Blur Exterminator aggressive over to the image I just cloned or created, drop it on there, and it's going to run Blur Exterminator, and you'll see it will greatly reduce the star size. It makes the stars almost too small and too sharp, which is why I run it twice. I'll run it once with very aggressive settings to get a good crisp core of the star, and then I'll run it a second time that creates what I call the fluffy stars. It expands the halo around the stars, which is where more of the color is located. And so by running it twice and then blending those in Photoshop, we can control how big or small we want the halo, how intense we want the color, and so forth. So this is just about done. It takes about 30 seconds, and then I just ramble on. So there it is after the first round of Star Exterminator. And now we'll run the second one, which is the fluffy stars. And for this we have the sharpened stars at 0.25, but adjust star halos cranked up to 30. And we're going to run this on the other copy of the data. So we're running Blur Exterminator 2 times on 2 copies of the data, and that gives us 2 different Blur Exterminated results, one with kind of crisp, sharp stars, and one with larger, fluffy stars that will be more colorful. And like I say, having those lets you mix and match in Photoshop to decide what look you want for your image and how intense you want the color, how big you want the star halos, and so forth. And it will vary depending on the base image. There's no one size fits all. So this is done now. You can't see it, but I'm watching this process monitor that's over here on my second monitor. If you wonder why I'm constantly looking back and forth, it's because I have 2 monitors, and the camera is above what would be my second monitor, just because that's where the shelf is the right height. If I put the camera up above, you'd be looking at the top of my head, and you might think I was losing my hair on top. If I set the camera down too low, you might think I have a double chin. So it's all kind of a compromise. So we have our 2 images here, one with fluffy stars, one with sharper stars. Now we need to stretch the image, and we will do that with the STF function. There's lots of ways to stretch an image. I do the final stretches in Photoshop, so I'm just trying to get a good starting point. So the STF is quick and easy, but of course we also need the histogram transformation to apply it. And so with the channels linked, I'll update my screen transfer function, and then I can use the mouse wheel to zoom in to see these sliders for the black and the midpoint. And I will usually darken the blacks a little bit, and I may brighten the midpoints a little. I don't want to drive the blacks all the way to black, so I'm watching those areas. And I say I'm really just trying to get a good range of tones that I can work with. So you grab the triangle, drag it down to the bottom bar of the histogram transformation, and that copies those parameters over. Click the square, and that applies it to the first image, and then I'll come back up and turn off the screen transfer function. Now we have a non-linear image, and then I'll just grab the triangle and apply that same stretch to the second image. So now we have 2 stretched images, and it's really becoming more obvious that the difference in star size between the fluffy stars and the sharp stars. So the last thing I will do is come down here to Noise Exterminator and Star Exterminator. And again, I have these process icons saved, and then this set where it says NXT/SXT, and then there's a second one with save stars. This is a process container, and a process container contains two processes, the Noise Exterminator and Star Exterminator, with settings to save the stars. And unfortunately there's a bug in the Star Exterminator, so the first thing I'll have to do is double click on, just open Star Exterminator and remind it what AI version I want to use. Hopefully Russ will get this fixed soon and I won't have to revisit it every time. And now I can just drag this process container over to the first image, and it's going to consecutively run Noise Exterminator to clean up the image, and then it'll run Star Exterminator to knock out the stars, and it will create a second image with the unscreened stars that we can use to put everything back together later. And typically what I do is I'll save the star image and then run this same process on the fluffy stars. And what I tend to find, and we'll probably see it here, the stars look great both times. That's really not a problem. The nebula image, that background image, it does a better job of cleaning up the fluffy stars than the sharp stars. So generally it'll be the fluffy stars that will use the background nebula. But we'll just see what we get when it's done running. We're up to about 85–90% now, so it's just about done with Star Exterminator, and it'll create the new file when it's done. So there's our stars. So we could save this, and you can see there's a lot of residue. Now some of these, if we zoom in, some of these are galaxies, so not everything is star residual, but some of these are clearly star residual. So I will save this star image as a 16-bit TIFF just through File, Save As, navigate to the folder where I have the original data, make sure TIFF is selected, click Save, and then it'll give you a dialog where you can select 16-bit TIFF. Then I'll run Noise and Star Exterminator on the fluffy star image. And I'm not sure why the Star Exterminator seems to like the soft stars with the larger halo a little bit better. And I think we'll see when we run it this time that it just does a better job of cleaning up the background. And you also probably need to be a little bit careful, because if it doesn't remove a star, if you have star residual on the nebula, then you probably are missing a star in the star field. So you do want to be a little bit cautious about that. We're just about done here, coming up on 90%, 95%, and it should be done about now. So here's our fluffy stars, and now you can really see the difference between the sharp stars and the fluffy stars. And as I suggested, the background image is much cleaner from the fluffy star version, although it still retained these galaxies. And we've got a little bit of a flare over here from a nearby bright star that we'll clean up in Photoshop. So now I would save this image as a 16-bit TIFF, and then typically I will increase the saturation of the fluffy stars, and I use curves with a saturation curve, and again I have that saved. This is the saturation curve that I saved, so that's already saved. I just apply that to the image by dragging the saved icon onto the image, and now I will save this. If it has a lot of cyan stars, I may run a SCNR to remove green, and that kind of knocks the cyan down to blue in some of those stars. Save this as a 16-bit TIFF, And at this point, we're ready to hop into Photoshop. So I think I'll end the first video here. I hope you found this useful. If you have any questions, obviously post them in the comments and I'll try to answer them. If you found this useful, be sure to like the video and subscribe to the channel, and that will help ensure that you get notified when I produce new content. And with that, I hope you have a great day today and an even better night tonight under a clear, dark sky. Thanks.